Dear friends, this is my tutorial 34. So in this tutorial I am going to teach you how to do and plot pre-resonance Raman spectrum using Gaussian and Multiwfn. So this is the calculated pre-resonance Raman spectra of S-methyl oxirane. So this is our Raman pre-resonance Raman calculation folder. So before going to do the pre-resonant Raman spectrum, we have to do two more steps. So first step is we have to optimize our structure first. So this is the S-methyl oxirane input file. Just I will open with Notepad++. So this is the input file. So first we have to give %chk equal to S-methyl oxirane, name of the system, and .chk. Then you have to give the memory, percentage memory equal to 6 million words. Then n/shard 2 you have to give. So if you are using Linux system, this may vary based on your Linux machine configuration. That fourth one, we have to give the root section keyword. This is the very important. Here you have to give that hashtag, then b3lyp/gen sudo equal to read and gf input. Then you have to put opt frequency keyword. These two things are very important because first the structure will optimize, then it will do the frequency calculation. Then you have to give one space, then you have to give the name of the system. Just I will mention S-methyl methylene. If you are using benzene, just you can type benzene. So you can also give some short keyword also. This is based on your convenience. Then you have to give one space. Next you have to give the charge, total charge of the system. The total charges of the S-methyl oxirane is 0. Then you have to mention spin multiplicity of the system. This spin multiplicity is 1. So this is the Cartesian coordinates. You have to draw using your Gauss view, and you save as a GJF file and copy paste this S-methyl oxirane Cartesian coordinate here. Then you have to give one space. Then you have to give what are the atoms present in the molecule. Here carbon, oxygen, H is there. So we have mentioned here 3 atoms. That this is the 0. You have to give the 0. Then you have to give the basis set of the basis set. So to do the optimization of this structure, then you have to give 4 star. 4 star means end of the basis set. Then you have to give some space. Then save it. So we have to why we want to give the space means then only the Gaussian will recognize that input file ended like that. So that's why we have to give space. If you are doing Gaussian calculation, you always give some spaces after the ending of your basis set. That's all. Now we can do geometry optimization of this molecule. So I will show you this molecule using Gauss view also. Open your Gauss view. Just drag this file to here. In that Gauss view, you will see the S-methyl oxirane structure. So this is the S-methyl oxirane structure. So I already submitted this calculation for geometry optimization and also completed, because this is very small system, it will take less time only. So I will open this with Notepad++. So this is that output file for that S-methyl oxirane. See, this is our root section keyword. So if you go down, you will see normal termination of Gaussian 09. So now we can see that summary of this calculation using our Gauss view. So just to drag this output file into Gauss view. So now you go here, result. In the result folder you can see summary. If you click summary, you will see that what types of calculation, the frequency and optimization calculation. So what basis set theory used here, you can see here, under the spin state and the charge. Then also solvation used or not. This is the total charges of the system, and also dipole moment, polarizability, everything you will see. So if you want to see the vibrational frequency of this one, just to go to result and click vibration. If you click vibration, it will a small window will appear. So here you can see start animation. If you click start means it will start animation. The first one is this CH3 vibration. Then click 2, you will see different kind of vibration. So likewise you can see all vibration up to 24. So that's all. Then you can stop. So you should remember that you should not get any negative frequencies in this system. So otherwise you have to do one more time geometry optimization, and you have to check the structure configuration. Then you have to redo the geometry optimization, get that positive frequency, then stop this one. So if you want to do further calculation, you have to use this optimized Cartesian coordinate. So this is the optimized one. So we will save this coordinate, like we can go to file and save. So just we can save somewhere. Opt coordinate, I just save for you. So here you see Gaussian GGF output file. Okay. So this is that we saved optimized Cartesian coordinate. So if you are going to use your UV calculation or NBO calculation or ECD NMR calculation, you have to use this Cartesian coordinate to do that kind of calculation. So already I used this, made the input file using this Cartesian coordinate. So I will show you the next step. So we will remove this, no need. So then second step, we have to do UV visible calculation, that S-methyloxyrin. So this is the UV visible calculation folder. So this is the input file for that UV visible calculation. So here you can see I mentioned that percentage CHK S-methyloxyrin pre-resonance UV calculation, like that mentioned. You can also give the short name. So here you have to give memory and enprochat, likewise with geometry optimization. Then you have to give the basis theory of your which theory you are going to use for this calculation. So I am using B3LYP. So this is the default keyword, already I told in the geometry optimization section. This is the important keyword for UV calculation. So I am using this UV calculation gas phase. That's why I did not mention any the solvation keyword. So here you can mention TD equal to singlet comma n state 30. So we will get the 30 state from S0 to different kind of state we will get 30. So if you want to 20, you can also mention 20. If you want to 50 states, you can also give 50. I think 30 is enough. Then you have to give space, then you have to give the name of the system, then you have to give space, then you have to give the total charge of the system and spin multiplicity. This is the optimized Cartesian coordinate of S-methyloxyrin. Then give space, then you have mentioned that what are the atoms present in the molecule, then you have to put 0, then you have to mention the basis set, then you have to put 4 star. 4 star means end of the basis set. Then you have to give some space, then you can save it, then you can submit this calculation your Windows system. It will complete 5 to 10 minutes because this is very small system. So that's all. So this is that our UV spectra calculation output file of S-methyloxyrin. Just we can open with Notepad++. So I will show you that transitions. So this is the excitation energy and oscillator strength you will get here. So this is the excited state 1. Okay, this is the singlet 2A. So this is the first nanometer. We have to use this value in order to do the pre-resonance Raman spectra. So if you want to check the second excited state also, we can use. So this is 138.76. So this is around 150. This is around 140 nanometer. So we are going to use this 2 value in order to do the free resonance Raman spectra. So before going to do a free resonance Raman spectra, you have to do your TD-DFT calculation. You have to get this 2 value. Maybe 1 also enough. You can also get the 2 transition. This is okay, no problem. So that's here. So you can go down means you will see the normal termination of Gaussian. 09. That means our calculation completed without any error. So next step we will do the pre-resonance Raman spectra calculation. So this is the pre-resonance Raman spectra calculation folder. So this is the input file for pre-resonance Raman spectrum. Similarly, like UV, you have to give that first line, then you have to mention that memory and N-proshat, then theory, then the default keyword you have to give. So this is the keyword for pre-resonance Raman spectroscopy. So you have to mention CFHF equal to RD freak, then freak equal to Raman. So this is the very important. Then you have to give space, then you have to give the name of the system, then space, then you have to put the total charge of the system and the spin multiplicity. This is the optimized Cartesian coordinate of this S-methyloxygen. Then you have to give the space. So already I showed this UV visible spectrum output file. I showed that 138 and 147 something. So we have to make a round off into that 140 nanometer and 150 nanometer. You have to mention after giving one space, you have to give this value. So this is the very important. This is the Raman incident light wavelength. So we have to mention. Then you have to give the space. Then you have to give the what are data present in the molecule, then 0, then basis set, then 4 star. Then you have to give enter and save this file. You can submit this calculation your Windows system Gaussian. It will complete within 10 to 15 minutes. So this is the our output file of S-methyloxygen pre-resonance file. So we will use this output file to view the pre-resonance Raman spectrum. So I will show you this file using Notepad++. So this is the our root section keyword. This is the very important things. If you go down, you will see the normal termination of Gaussian 09. That means our calculation completed without any error. So that's all. We have done 3 steps here. The fourth one is we are going to plot that S-methyloxygen pre-resonance Raman spectrum. So for that we want Multiwfn software. You can download this software from the website. So just Google it, Multiwfn. You will see 3 kind of version: Linux and Mac OS and Windows. So go for Windows version. This is very easy to use. Okay, you can download it and you will get the zip file. So that zip file you can extract it. You will get this folder. From there you will see this kind of files. So this is the application thing. So Multiwfn, just you can double click, it will open. Just we can double click, so it will open like this. So now we will plot our pre-resonance Raman spectrum of S-methyloxygen. So just now we have to enter. After opening, just you can click enter. So you will it will open that folder, corresponding folder. So if you're not showing that corresponding folder, you have to give the path. So you can go to path. Here I did different kind of spectrum. So we are going to do pre-resonance Raman. So here, so this is the my folder. So this is the optimization folder. View visible is pre-resonance Raman. So here you have to choose our output file dot or this the out file. Just you can select that one and open. It will open with that main function menu. So now we have to choose what we are going to do. So what we are going to do here, we are going to plot this pre-resonance Raman spectra. For that you have to type 11 and enter, and it will ask which select the type of spectrum to plot. Here you can see the different number as different spectrum. So here what you have to do, 1 for IR, 2 for Raman or pre-resonance Raman is there. So we have to choose 2, just 2 and press enter. It will ask recognize a Gaussian output file. This is the pre-resonance Raman calculation frequencies of incident light. So we have mentioned that input file. So 149.99, that means 150 and 140 we are 150 and 140 we have mentioned. That's why it's showing that 2 and 3. So if you want to plot with 149 nanometer, you can also plot. If you want to plot 139.9 means this is 140, you can also plot. So I will show you how to plot. That's 150. For that we have to select it number 2 and enter. and you will see like this. So here what we have to do, we have to scale the vibrational frequencies. That is very important. So first for that you have to select this 14. So select type 14 and enter. So then it will show there are 21 frequencies in total. So if you enter that, you will select all frequencies. If you want to select a specific frequency also, you can select. So I want to do all frequencies, so that's why I press enter. That means it will take all frequencies, 24 frequencies. So it will selected as 24 frequencies. So we have to give now scale factor. So this is a very important. So here see default scale factor, it will come 9614. So I will show you where to get this scale factor value. So go to Google. So type vibrational frequency scaling factors. If you click that, you can search this keyword, you will get this first one. This is a CCC BDP listing pre-calculated vibrational scaling factor. Just you can click it. So you will get this page. Here you can see, so this is the theory we are using. So basis set is 631 G star. This is our basis set. Okay. So 96 is that. So we can choose 0.96. So here we can type 0.96. Then enter. That's all. I think everything over. So now we can see our plot, pre-resonance Raman spectra plot. That is very important. So just to type 0, see here 0 means plot spectrum. So this is our Raman pre-resonance Raman spectrum of S-methyloxyrin. If you want to save this image to your corresponding folder, we can save it easily. Just we can right click, we will close. So you can see here option 1, save graphical file to the spectrum in the current folder. Just you can type and press enter, it will save. So if you want that XY dataset file also, we can save. We can use this XY dataset file. We can use Origin software to plot this pre-resonance Raman spectra. So we can get the data also by typing 2 here and then press enter. You will get that file also. So I will show you that 2 files. So here you can see this is that image file saved one. So this is the pre-resonance Raman spectrum of S-methyloxyrin. So this is the 2 kind of file will save. One is the spectrum and the curve type. One is line type. So if you want to, you can use this curve type. You will get that like a curve-like structure. So you can use this file to plot using the Origin software. You will get your good beautiful spectrum of that pre-resonance Raman. I think everything is fine. This is calculation is over. So you can also do. So thank you for watching my video. If you like my content, please like, subscribe, comment and share, and also please click the bell icon for future video update. Thank you so much for watching. Enjoy.